Hi, my name is Sean Olson. This is our second video on the introduction to 3ds Max for Hammer users. In this video we're going to cover materials and unwrapping and that kind of thing to get your textures onto your objects. In the first video we covered creating objects and moving them around in simple basic manipulation in most of the items in this main toolbar or several of them. Right now we're going to talk about the material editor. So this button here, if you hold it down, you'll see two options. We have the first option here, which is the legacy compact material editor, and the second was Slate. We'll open up the old one first. You'll see a lot of old documentation that shows this version. And most of the documentation on Wallworm and most of the videos, we're going to use the other one. So we can swap when we have this open by just clicking modes and go to the Slate material editor, and it will change it. Let me close this again and to show you. If we just click this, if we click this one, it will bring that up. Also, I'll close it again. M on your keyboard is the shortcut to bring up the current material editor. In the previous video, we covered some of the material editor. We'll reiterate some of those points and we'll go further. The material editor is where you mix and match and make your materials. It's very similar in many ways to other systems you may be familiar with, such as Substance Designer. We're going to start by just adding a box in the scene, and similarly to the last video, we're going to apply a material to it. So by default, any object you have usually doesn't have a material. You may see a color on it, and that color is actually what's called the wire color. In fact, if you look over here in the command panel, you're going to see the current wire color for this object. If I double click it, I can change to a different wire color. In fact, even if I render the scene, it will use that color. It's a very basic default flat shading color, and it's not a material. A material is a far more complex representation of how surfaces look that include different types of lighting and bump maps and various other attributes about how the surfaces of an object look. 3ds Max comes with several types of materials, and depending on what you're doing, you'll use multiple different versions. And over here on the left on this material and map browser, you're going to see that we have under materials a general tab and a scan line. Now scan line is now considered more legacy materials, and in the general tab you'll find all the materials you use for more modern workflows usually. And by default, for a lot of rendering purposes and newer engines, you'll want to use the physical material. However, I'm going to focus on the legacy standard material because that is the material that you should generally use when using Wallworm and going into the source engine. To work with the material, all we do is select it over here in the material and map browser and drag it out. Also, as mentioned in our previous video, you can right-click an empty spot of this slate view and you'll see the same menus. We have general and scanline, and we can create a new standard material here. I'll double click this one, and notice by default the materials will get a name. It'll usually be something like material with a number. You should get in the habit of naming your materials for multiple reasons, even if you're not using Wallworm, because it will help you find and sort and match and get the materials you need. In fact, we'll type this. I'm going to type examples/box1. Now, a lot of times you don't use slashes, but when you're working with Wallworm and going into the source engine, these names also relate to the final path of the materials once it goes into the game. So it's a way for you to organize and name your materials at the same time. Now I'm going to apply this material to this box. One way is to double click the material so you see this dotted outline. That means it's the currently active material in the material editor. And click this button that says Assign Material to Selection. Once you do that, it will be assigned. Conversely, you can also drag this output node by left-clicking and dragging, and also apply it to an object or the current selection of objects. Once that material has been applied to your object, anything you do to this material will be applied to that object. So in this case, I'm going to change the diffuse color. You'll see in the viewport that it changes. So far, this is really no different than applying a flat color through the wire colors, except for you'll find that the rendering may have more shininess, etc., because this standard material does have specular color and these glossiness values that will take the lighting into consideration. So right here we're working with a material. Now when I first started 3ds Max, I was a little bit confused on the difference between a material and a map. A material is the complete final result of the surface of an object, whereas a map is just a component of the different attributes. So for example here, if we open up this map slot, this material has a bunch of different slots, texture slots, for us to add to control the different attributes of how this material looks. Common ones that you'll want to use are bump, glossiness, specular level, opacity. Which map you're going to be using is dependent on the effect you're trying to get. And when it comes to wall worm and exporting to Source Engine, only some of these will map to different properties in Source Engine materials. Those include the diffuse color, specular level, self-illumination, opacity, and bump, and in some cases a few others. So notice over here in this map and material browser, I'm going to minimize the materials, and you'll see another group called maps. If we open up the general, we'll see most of the legacy maps. Some of these are custom ones that are downloaded or come with other plugins, and some of these are ones that come with 3ds Max. Among those are ones like bitmap. If I drag this out here, I will see bitmap, and it will allow me to browse for bitmaps on my system. I'm going to double click this bitmap and it will be loaded into the slate view. Again, if we double click this, now this is the object, you'll see the dotted line around it, that's currently in our material editor. So now the parameters that are available over here relate to the currently selected node. Again, we'll go back to the material so you can see. If we go to the material, it has all of the settings for the material. Go back to the bitmap, and now we have the settings just for this bitmap. If I drag this bitmap into the diffuse slot, now that material will use that texture for that slot. In this case, I put it in diffuse, which is the color that you see. Now notice I'm not seeing it in the viewport. However, if I hit render, you're going to see that the texture is now on this object. If you want to see your texture in the viewport, double click your material and choose this option to show shaded material in the viewport. Now you're going to see the material in the viewport. Now we're going to again go and explain a few of the differences between these map slots in the material. Let's bring our view out here so we can see this a little bit better. As an example of how you can, at the base level, reuse a map, I'm going to put this same map into the bump slot. And this texture is really not made for a bump, but you can see the effect by just doing something like this. So you can see this texture has a certain look right here. If we re-render it, it has a little bit more pronounced effect. And let's add a light down here so we can see this a little bit better, so we can see what the bump will do. So now if we render this, you're going to see, let's make this brighter, maybe a little too high. You're going to see what's happening is the surface looks like it's bumped out. And again, this texture is not really designed to be used as a bump. We'd want to make one specifically, either using a height map or a normal map, which we'll go into that in a little bit. But now you can see, if we go back to our material editor, that this bitmap is now going into two different slots. It's going into the diffuse for the color and the bump, which creates the effect of a 3D surface. Now, since this bitmap really isn't made for a bump, we want to remove it. You can do that by selecting the wire that's connecting the output socket of the bitmap to the bump slot. Once you have it highlighted, you can just hit delete on the keyboard and remove it. So now when we go to render, we're going to go back to just having a diffuse, and we'll go into using an actual height map or normal map later. So now let me maximize this again, and we're going to double click on our bitmap again, because just like the material which we gave a name, the maps also have a default of map with a number, and we don't want that. We want this to be something more descriptive. And again, with wall worm, you'll want to use a path, so that will be the final output of the game texture. So I'm going to put again here examples, and I call this bubble moss, and that will be the name of it. In fact, I'm going to name it VTF, because that means when I'm going into the source engine, that's the name of the texture file that it's going to represent. Notice over here in the parameter editor, we see a bunch of parameters that deal with changing the way this texture is transformed. There are UV coordinates for this texture. There's also other parameters, including a noise rollout. We're not going to go into that. We have this button here that says View Image. If you click it, it will show you the complete image. And we have an output rollout. In this output rollout, which is available in many maps inside of Max, likewise, this coordinates rollout is available in many. If we go to this output one, you can change things such as the output amount. So as I drag it up, you'll see that the texture gets brighter or darker as I change that. I'll keep it at 1. I can also enable this color map and go down here. I'm going to go to RGB and say I want to reduce the red in this texture. You're going to see it becomes more blue and green. I'm going to disable the color map, bring it back to normal. And you'll notice a minute ago I had suddenly made this texture preview a lot larger. You can do that by double clicking the actual image. So if I double click it when it's large, it'll go small. If I go up and double click the small one, it'll get large. So that helps you see the image a little bit better. We're going to go back up here to this coordinates rollout and actually utilize it a little. So let me bring this down here. We'll see our whole box. So what these U and V offsets, tiling, and angles do is control how the texture globally, no matter what object is using it, will change. So if I change the U offset, it's going to slide the material around or slide this texture around. That's in the U, this is in the V, and here's W to rotate it. You can also change the tiling, so let's go to offset back to 0. If we change the tiling, you're going to see that it gets smaller or bigger in the axis U or V. Put this back to 1. This is a good way to change the way this texture is applied in the entire scene. So if you have multiple objects that are using this same texture, then they'll all be using the same transformation offsets. And when I shift dragged it, you're going to see that it has this option to make a copy, an instance, a reference. In this case, I'm going to make a copy. That will make these objects all separate, controlled separately. If I make it an instance, changing one will change them all. But I'm going to make it a copy so they're all different, and I'm going to make a number of copies to 3. So now we're going to see that it made multiple copies along that direction. And you're going to see here, as I change this, all of the textures are changing globally among all of the different objects because they're all using the same material, and this texture transforms are applied to all of them. So controlling the UVs and the textures on objects in Max is sometimes confusing for some people, especially when you're first in it. Because right here I'm showing you that we're transforming these inside of the material, but these are transformation offsets that are further applied from the object's UVW coordinates. So every object itself has its own UV coordinates. And to see what I'm talking about here, I'm going to select this object and make it a lot wider. Move this one out. Make this one a lot taller. And now you're going to see here that these are all stretched in different ways. And the reason that is because the UV coordinates that these objects already has coordinates applied to each of the vertices around the objects. And we can visualize this if we click on Standard up here in the top left of the viewport, go to Materials, and we're going to use what's called the Override UV Checker. So what it's going to do is show us a chart of the UV coordinates. And you're going to see that if we go to the first object, everything's uniform for the most part. In fact, if we make these numbers all equal, the size on all of these, then all of these UV coordinates are square. But you're going to see that in all these other ones, on this face of this one, it's even, it's square. However, it's stretched out on these other faces, on the other sides. Same over here, it's stretched out in these different dimensions. So the UV checker is a way for you to see how these UVs are, if they're square or not. We're going to go back and turn that off and go back to our settings here. Now we can still slide these around, but they're sliding at different rates because of the UVs. They're not standard. Now we still have a per texture way to get all of the displayed UVs on these objects uniform, and that is using what's called RealWorld Scale. You'll see over here in the bitmap texture, there's a checkbox that says use RealWorld Scale. If we turn this on, we now have an option in here for size, width, and height. They're essentially doing the same things, but they're doing it in a different way. The one caveat is that RealWorld Scale only works on certain types of objects, such as the primitives here, like a box primitive. And to get it to work, you're going to see a checkbox over in the Modify tab called RealWorld Scale. So I'm going to go to this first object, let's zoom in here, and we're going to turn on use RealWorld Scale. And immediately it looks horrible and muddy. The reason is, let's zoom in really close to here, you're going to see that it's tiling at a very, very small value. And the reason for that is it's using RealWorld Scale, and the scale right now is set to 1. So if as I bring this up, you're going to see that it's tiling now in this dimension every 21 units, but still every 1 unit for this other. So I'm going to type in values here of 128 by 128. Now you're going to see that this is tiling every 128 units, no matter what. So on this box, which was already square, it doesn't really matter too much. But let's go over here to this object, and let's turn on Real World Map Size. Now you're going to see that it also is tiling at 128, 128. And regardless of what the UVs on the object were, by default, it's now using the textures scale to represent the tiling. So again, we can go back to this other object and go to all of these. And now any changes we make will be equally represented on all of the objects. So if we change the width of these, the offset width, they're all going to slide at the same unit. So if we want to slide them all at 512, they're all going to be offset by 512 from where they were. Likewise with the scale, which is the size, if we want them to all be 256 units by 256 units, now they're all tiling every 256 units in the world. RealWorld Scale is very effective when you're designing things with certain primitives. Pretty much most of the default primitives in Max, like the box, the cone, the cylinder, all of these will allow you to use RealWorld Scale. So if I create this cylinder, again, there's a real world map size you have to turn on to use this. And once you have that, if we apply this, this also will be utilizing the exact same real world scale. And again, that's for enforcing the material to control the actual physical dimensions of the object. Now there is the problem that only certain types of objects allow using real world scale. So a lot of times you're going to have to use other strategies for applying your textures and getting the right scales and sizes that you want for your textures on the objects. So now we're going to go and discuss those other type of scenarios. So in this case, let's convert these to editable poly. So I'm going to select all of these objects and do convert to editable poly. When I do this, we are going to see that if we zoom in here and change the sizes of these are actually transforming still. But we're going to run into issues if we start editing these objects in different ways. For making this easier, we're going to go to the polygon subobject level and we're going to start extruding this out and turning it into a different kind of object here. All right, now that we have this little object here, we're going to isolate it. And notice how the UVs are completely wrong here. And the object, it's just skewed really badly. And let's go back to our UV checker here. And the UV checker is looking odd because probably the real world scale. We're going to turn that off for the moment. And I believe this is an artifact of the material and UV scale. So we'll just put on the standard material here. At this point, we'll discuss another map that can help you visualize things. And that's the checker map, which is again part of the legacy materials. You can also use the checker map down in what's called the Open Shader Language section, OSL, and you'll find another checker map I'll go into the OSL things later. So we're going to use the default checker map. We're going to pull this out here, drag this into the diffuse of our object, of our material I mean. I'm going to name this examples checker for the material, and copy that and name the same thing for my BTF for the bitmap. And again, we don't see the material on this object even when we apply it. And the reason is, again, by default it doesn't show the material. So I'm going to click on this button to show shaded materials in the viewport. The reason why we're not seeing this, and actually probably why the UV checker isn't working very good here, is because when we converted this to an editable poly, it used a very small value for the UVs here. So we're going to actually go back to the UV checker here and see if we can get these UVs to display as we'd expect here. So we're going to go to the Modify tab when we have this selected, and we're going to apply a default UVW map to this. And we're put it, by default, it's projected from the top down. You can see it looks pretty much correct from the top, but from the sides it's all skewed. At the bottom it's correct too. And that's because this modifier is just projecting onto the object a planar UVW map. For our cases right here, for what we're going to do, we're going to choose box. And this is a lot better than what we had. It's still not perfect, but now we have UVs that kind of look like we'd expect. Now we're using UVW modifier. The way this controls it is actually at the geometry level rather than at the texture level. So in this case, if we change the height, length, and width of it, you're going to see, if we go from this view, you're going to see that it's changing the length in that dimension. If we change the width, you're going to see it go in this dimension. And if we change it in the height, you're going to see it go in that dimension. You can type in specific values to make it square. So in this case, we'll do 256, 256, and 256. And you can further offset those with changing the tile values. We're not going to do that. Now when we turn off this UV checker, you're going to see it shows our texture, our checkered texture that we had here. Now again, just so you understand that the UVs of the object, let's put this over here so we can see all of this at once. The UVs on the object and the UVs on the texture are combined. So in this case, right now, the UVs of this object are such that they're going to tile every 256 units because of the UV modifier. However, the texture can further offset that. So if I want to change the tiling over here, I can. And that's offsetting on top of the UVs of the modifier. Again, if I go back in here and change these, you can see how they're offsetting. So it's not tiling every 130. It's actually tiling every 130 and divided by this tiling value here. So if I put this back to 1 in the texture, now it will be tiling every 130 units. So that's important to understand how these two interact with each other. So let's unisolate this selection so we can see all of our objects again and apply this material to our cylinder here. Now because the material that was on there and was using RealWorld Scale, and that scale is completely different than the way that this editable poly is working. Let's select it. We're going to have to do the same kind of thing to see the materials correctly. So we're going to add another UVW map modifier. And again, the default planar is projecting from the top, and this is not what we want. Luckily, there's one called cylinder. If we project that way, it's going to tile around the object like this. And if we want the tops to have correct UVs, we're going to have to choose cap. And now it's projecting onto this object in this way. And I can change the parameters on this again. I can change the height of it to change the number of tiles up and down. Or I can undo that and keep it there and just change the tiles in the V here. So if I want it to be exactly 2, I can put 2. Let's go back down to the base level here. We'll scale this up. to show you what that means. So as we go up, make this bigger, get out of the polygon level here, it's scaling 2 per the size of this gizmo instead of the whole object. So that's another thing we're going to have to discuss here, is the gizmos of the UVW map. When we first applied it, it created a cylinder gizmo that is a specific height based off the height of the object. If we want to change it to match the height of this object, we can actually go back and just hit this fit. And now it's tiling twice per height. We can actually go back into our sub-object and move the sub-object. In this case, I can just slide this around, up and down. I can even rotate it. Again, we're at the gizmo sub-object of the UVW map modifier. And again, as we mentioned earlier, each object has its own per object UV coordinates, and then the material or the texture's UV offsets are being multiplied on top of that. So in this case, let's go back to our checker texture, and we're going to see that these are completely different scales because of the UVs on the objects, but still, if I go back to this checker object and I change these offsets, they will still be applied to both of them. They're multiplying the values on top of the values supplied by the object. So if I change these tiling values, you see they're going to get a lot smaller in that axis. It's applied to both objects. So let's get this back to 1 and 1, and we're actually going to delete most of our objects here and start over from scratch. And we're going to talk about a type of scenario where you can't really use these very basic UV projections, and we're going to have to use something called unwrapping. Convert this down to an editable poly. Let's make this a little bit more organic. So now this object is a little bit, has different areas that are kind of sticking out in different ways. And if we apply a UVW map to this, we'll do box for the moment. The box does a fairly good job at this. However, there's places where the textures are skewed slightly, and especially when we do to the next step. We're going to actually add another modifier on top of this called a turbo smooth modifier. Depending on what you're doing, you may want to look into using another one called open subdiv, but we're going to use turbo smooth for now. We apply this, you're going to see it's a little bit skewed and janky. In fact, we're going to take our modifier and bring it back on top of this. I'm going to drag it above. And the reason I'm doing this is that was a little bit better, but still it's skewed and it's jagged in areas. And I want to create an unwrap for this that's a little bit more seamless. And let's look at the UVs with our UV checker. You can see places like this that's jagged in here. And the default box one isn't going to get you where you want all the time, especially the more complex your geometry is. For example, this section here and this section here. We're going to now talk about the Unwrap UVW modifier. We're not going to go into extreme detail because there's already a ton of videos that will help you understand how to use this. But we're going to cover it here because it's an important element. I'm going to go take off this UV checker mode. So now we're just showing the actual texture checker that's on this object. And again, you see some of the skewing here. We're going to add, I'm actually going to convert this to an editable poly. We're going to add a UVW, an unwrap UVW modifier. Now you're going to see all of these green lines on it. If I scroll down in the Modify tab, you're going to see here in the Configure option a group called Display. These are the map seams. Those are the places where the UVWs are split. And these are the peel seams, which we'll discuss here in a moment. So let's go up here, and we're going to open the UV editor with this button. Bring our object over here. And here's the mapping of this object. And it's kind of hard to tell where everything is, but if I select a polygon in the view, you'll see it highlighted. And if I select one over here, you'll see it highlighted back and forth. So I can select multiple things, and the selection goes back and forth. And in here, I can move the UVs around. So if I wanted this to be moved around, I can do that here. But this is not at all how I want these UVs to be for this object. So we're going to discuss how to unwrap things. And again, this video is going to be very primitive on this topic. So you'll want to watch more advanced videos. Basically, we just have to think about this being something we want to put down on the floor as a rug. And how would you chop it up? And there's different ways to approach it. What I'm going to do here is just draw these lines. Actually, I'm going to get rid of the current seams and only show the peel seams. So the blue is the peel seam. So this is where it's all going to be peeled. In fact, I did a smaller circle on that side. Yeah, I'm going to undo that. Go up and do a smaller circle over here too. And now we have a few different pieces. Actually, we need this cut around. And we may end up going around like this. So basically what we've done is quickly decided how we're going to chop this into several pieces. Okay, and to make this make sense here, I'm going to switch to polygon subobject mode, which is right here. I'm going to undo check element. I'm going to click a polygon in the view here and hit expand to all. So you're going to see that it expanded all the way to these blue borders here. And then I'm just going to hit pelt map and hit start. And I'm going to go to the relax and commit. So what you're going to see here, in fact, I'm going to turn on this checker pattern here so we can see what happened was this is now one solid piece that's been flattened out. So you can think of it as if this was some creature that you were cutting up. This could be one piece of a rug. So now we're going to do the same thing to these different sections here and commit them. Let's expand it to all, relax it some. And this piece, we'll see if it works okay here. All right. And commit it. So we're going to expand a selection, pelt map this, start, commit, move this out, expand a selection, pelt map, and relax it, commit, and let's see, where are these pieces? All right, down here to this nose piece, expand a selection, pelt map, all right, and it looks like we have all the pieces. Now what we want to do is we're going to select them all and we're just going to lay them all out and give them a padding. I'm going to make it a really small padding, and we've laid them all out into the UV space. And by using the option for rescaling them and rotating them, it tries to fit them all at the same texel density. So all of the squares along the whole thing should as much as possible be the same size, so you won't see any stretching very much here. Now, this automatic packing may not be perfect. You may find that you can pack it better yourself. To do that, you would select all of the pieces, and we can hit Control to scale them to keep them square, and then we might be able to just move these around and get them to fill up as much of the space a little bit better. So your goal here is to make this fill up the space. So I can, if I right click this and choose, it's already on the freeform, a middle handle on the top and right sides, we can rotate it. So let's rotate this some to try to get it to fit without touching. You can't go outside the border here, and you don't want them to overlap anywhere. So you don't want any polygon anywhere to overlap any other polygon. In this case, I might move it over here instead. Now this doesn't seem to want to fit right here, so we have to make decisions. Did we scale it too much, or do we need to cut these pieces up a little bit more in order to use as much of this texture space as we have? But I think that maybe if we move this around over here, and let's rotate this, we might be able to get this to fit in here. As long as it's not outside the border, and as long as they're not overlapping, you're okay. But once it starts overlapping or goes outside that border, then we'll have issues. So what we've done here is we've used up a little bit more of the texture space. Any of these gaps between the islands thus becomes wasted space, because in the end, the whole point of unwrapping like this is allows you to bake your textures down into a bitmap, and that's what you need to do to get into a game engine in many cases. We got this sticking out the side here. So this covers the basic minimal understanding of the Unwrap UVW editor. You have many tools, and this is only a very basic discussion on how you would chop up an object. The more important the object is, the more time you may spend doing the unwrapping. There's all kinds of tricks and techniques that you might want to learn about, and there's plenty of videos by Autodesk and other professionals that show you how to use this tool effectively. Again, the main thing here is to remember to try to flatten and relaxing the whole thing out, and try to use as much of the UV space as possible. We could take more time probably on this and actually do a better job, but this is a basic example of the usage of this. So for the level design purposes, we're not really going to use this Unwrap UVW very much, because we want everything to be tiling textures, and obviously this isn't tiling right here. But the purpose of this is for your props, and we're going to show exactly how and why we did this though. I'm going to turn off the checker pattern and put on the actual texture. We wouldn't really use a UV or a checker for an object like this, but we needed to unwrap it in order to use more complex shaders and to be able to send into the game engine. So we might want to use what are called procedural textures and then bake them into this unwrapped texture. So now we're going to go discuss some procedural textures here. A bitmap is not a procedural texture. Every pixel of the bitmap is already defined. That's why it's called a bitmap. Every pixel is a bit of information. This checker map actually is a procedural, but it's very simplistic, and it's called a 2D procedural. What we want to do is actually apply onto this a 3D procedural and make this a lot more, we're going to give this a lot more depth and character, and then we're going to bake it down into the 2D bitmap. Now, if you're using 3ds Max 2019 or later, you probably should start using all of these OSL maps for designing and constructing procedural textures. In fact, Wallworm itself comes with a bunch that are source engine related, and we're not going to go into using the OSL maps, but you may want to use these in your workflow. I'm going to stick with the legacy ones for this video because there's going to be a lot of users that are still using the older versions of Max. So we're going to do some traditional types of ways of of creating a shader tray with procedural textures. So in this case, let's assume that this is a stone relic of some kind. Maybe it's a little statue that's used in some ancient ceremony. So we want to turn this into like a stone texture, not this checker. So we're going to use a few different maps on here. We're going to create a shader, and we'll use a cellular map. And we're not going to use this checker anymore. We're going to use this cellular map. And you can see here that the cellular map is being displayed in the viewport, and it has breaks at these seams that we made. However, if we hit render, you're going to see that it looks different. And the reason for that is the maps for these 3D procedurals do not always look the same in your viewport. So a lot of times you'll have to hit render. Now again, the OSL maps that you see further down here have a better representation in many cases in the viewport in real time. Now you'll notice that when we do hit render, that the texture is seamless. There are no seams. Now in the viewport there isn't. If we do want to get a closer representation, we can select our material and drop down and choose this option here to display realistic materials in the viewport. It's closer, but it's still not perfect. Now if we hit render, it's a little bit closer. But by and large, you may just have to hit render to actually see what you're getting there. To help expedite the process of seeing what you're getting here, you can hold down this render button and choose this one with a little play icon. It will bring open an active shade, and it went into my other monitor, so I'm going to bring it over here. So what will happen with the active shade is any changes you do to your material, it will automatically re-render. So if I change the cell colors on this to blue, it's going to re-render. So if I change the size of these to say like 32, you're going to see that it re-renders it automatically. So that way we can see all of the changes we're doing in pretty much real time. I don't want this to be blue. I actually do want this to be white. This is just going to be a mask actually between different sections of this rock. Shift dragging a node will make a copy of it in the slate view. So I went ahead and paused the recording while I took a few minutes to just create a very simplistic shader that's a bunch of noise, mostly just noise maps and a Perlin marble map, and output them into this material. And now we're going to add another element on here. So we have a basic rough looking texture on here, and if this totem might have had some paint from some people who painted this years and years ago, we want to actually just paint on our object. And we can do that in Max. Now there are a couple options when dealing with wanting to paint on objects. One is to use vertex colors, but we're not going to do that in this case. We're going to actually paint a bitmap onto our object. So first, to do this the way I want, I'm going to add a composite map on here. The composite map is basically just like a layered bitmap, similar to in your bitmap editor like PhotoPaint or Photoshop. I'm going to put a couple layers here. So I'm going to put layer 1 being our map, and then I'm going to make that the diffuse slot. I'm going to double click on this composite map and add another layer. This layer is going to be where I'm going to paint on. At this point I can minimize my slate view, and I'm actually going to close the active shade for now. And I'm going to select my object here, and I still have an unwrap modifier. I'm going to collapse this down onto the editable poly. I'm going to click Tools and go down to what's called Viewport Canvas. I'll snap this over the side here so I don't have to worry about it blocking my view. And I'm just going to click Paint. It's going to ask me what I want to paint on. I'm going to choose the Diffuse Colors Layer 2. There's nothing in there, so I'm going to choose and create a bitmap. So for the moment, I'm going to choose 2048, 48, and my background color is going to be black. And I need to save this texture, and I'm just going to save this as a TGA and call this example totem. All right. And it's going to use map channel 1 because that's what we unwrapped into, and that's very important. So this lets us start painting. I'm going to look and see what materials it has. I'm going to start with concrete, and this isn't concrete. I'm going to shift drag to bring this up, but I'm just making a base layer on here. We can adjust the layers with the color balance and levels, etc. I just want this to be darker, a little bit less saturated. And this is, oh, I right-clicked accidentally, and I didn't mean to. I want to go back and keep on painting on this. So I'm going to add a new layer on top of that, and let's assume that this thing had some color. Fill this in with red. And we can bring the opacity of this layer down some. Let's do another layer where we had some eyeballs on this thing. And let's just add a little bit more brightness to it. So now we have some really strange little totem creature from the past, and we have a basic bitmap that we've added. We're going to actually flatten layers and save it as a current texture. And now we're going to go into our material editor. We're actually going to put this below. Actually, we'll keep this on top, but we're going to assume that this is really faded. We're going to change this to the opacity of very low. Our viewport isn't updating very well here. So we're going to just assume that it had these old paint levels that were pretty much mostly faded off. We'll do it like that. So now we have this procedural texture and a mixture of the procedural plus this bitmap that we painted on here. Now we need to bake that all together into one flattened bitmap. And that's where the unwrapping we did earlier is used for. Also for our painting purposes, you can see we painted onto this into the unwrap channel that we had did. So I did a little bit more tweaking to fade out the material, to fade the painted layer more like it's more deteriorated. So now I want to bake this into a version that can go into the game engine, because again, this, I'm going to hit C here to lay these out. This bitmap or this shader tree cannot go into the game engine because all these procedural textures, those don't translate. So we need to bake it into bitmaps. Now there's different versions of Max and different ways to bake things. I'm going to use render to texture. I select my object. I'm actually going to name this totem so that it will default having some of these materials the way I want them. I get rid of the viewport canvas now. I can get rid of active shade now. And we have it selected, hit 0 on the keyboard. You can also click rendering and go to render to texture. There's a few things in here. We want to up the padding value. I'm going to up mine to 16. You can look in the docs and understanding why I did that. We're going to use the existing map channel, which was the channel that we unwrapped to. And I'm going to add whatever bitmaps I need to render out here. In this case, I need a diffuse map, I need a normal map, and I need a specular map. Add these elements. I want these all to be larger. So I'm going to select each one and change it to 2048 so we get more resolution here. And we can change the names if we choose to. Right now we have this being totem, which was from the name we have, and then adding the type of map, the name specular map. For mine, I like to actually just change it to S for specular, underscore D for diffuse, and underscore normal for normal. At this point, we can render it all out. So we're just going to choose render material. Now, when you see it rendering out here, it's going to be a composite of the final output, which includes the diffuse, the specular, and the normal. You'll notice that now in the viewport, we're seeing the final results that is the baked texture on here. If we open up the material editor and we click the picker tool, we can pick this object, and you're going to see that it has a new material here called, it's a shell material, where it has the original material and it has this new baked standard material, including our diffuse map. If we double click that and hit view image, here's our diffuse map. If we double click the specular map and hit view image, here's our specular map. And if we click on this normal map, you're going to see here's the normal map. Now, this did not cover the advanced functions in using render to texture, which includes using a projection modifier. Also, for getting the results you really want, you oftentimes want to go to your renderer settings and adjust the anti-aliasing or the super sampler. And again, this is a very simplistic, we made it a very quick shader of for this little totem, and it's not complex and it's not super high quality at all, but you can now see how you can take a procedural material that you create with however you want to make it, with all the different maps that are in Max. So you can see that there are a lot that you can use to generate the material, and then you bake it down into the game assets. In this case, I did a diffuse, specular, and normal. And now we're going to discuss applying multiple materials to an object. So I'm going to make a couple boxes here. I'm going to make my grid size a little bit larger and make these boxes. This might represent a chamber that's around, actually I'm going to turn off snap to vertex, only snap to the grid here. The chamber that's around this totem. And these might be walls. And we may need to have different materials on different sides of these walls, and the materials might have different UVs that are necessary for those. So we're going to talk about how we might control all that in a simplistic manner. So first we're going to create two materials to use in here. We're going to call this, remember we'll make a path for it, examples, inner walls, inner wall. That's the name of this material. Shift drag it to create another one, and this one's going to be outer wall. And for the moment, I'm just going to change the colors of these a little bit so they designate different areas. So the inner ones are going to be blue, and the outer ones are going to be greenish for now. Now the question is, how do we apply these different materials to them? Now, there's different ways to solve this. We're going to first start with using just one object here and using a type of material called a multi-sub-object material. So if we go to the materials, right click, go to general, and there's one called multi-sub-object. So what this is a wrapper to contain a bunch of materials that are going to be applied to different faces of your object. And they're applied by what's called a material ID. So we'll apply the first one to material slot 1, and the second to material slot 2. And apply this material to our object that we have selected here. And you're going to see by default it only has the top and bottom, and one is the bluish and one is the greenish and the rest are black. It's because all the others of this box by default have different material IDs applied to different faces. I'm going to double click this multi-sub-object material and set the number to 2. So we're going to discuss a couple ways to get the materials on this object in different ways. So I'm actually going to select, let me turn on a function in here so I can see which objects are selected more easily. I'm going to select these 3 objects and apply this material to them. So there's 3 objects with it, and I want the blue to be on the inside and maybe the tops and bottoms and the green to be on the outside, or something like that. So one way to accomplish this is to add a polyselect modifier, and this allows me to just select different faces of the object, and I'm going to select everything, and then I'm going to add another modifier called the material modifier, and this is just letting me assign a material ID. I'm going to put on all of these material ID number 2. I'm going to do the same thing again, add another polyselect, and this time just select the inner walls. And I'll add another modifier, another material modifier, and this time set it to 1. So now you see that the tops and the outsides and the bottoms are green and the insides are blue. This is one method of controlling this type of thing, and we're going to show other methods later. But now let's go ahead and say that these materials have textures on them. So let's add some textures. In this case, I'm going to use substance maps because 3ds Max will allow you to natively load substance materials or substance maps. I'm going to right click in the view and choose Maps, go to General, and choose Substance. Now this is important. There are different versions of the Substance plugin. The one that comes with Max and the one that Algorithmic has updated more recently. There are caveats with both of these. The first issue is, as of this recording, Substance 2, which is the newest version, has many bugs, and I'm going to avoid that one for now. The other caveat is the one that comes pre-installed with Max, Substance. It doesn't load the newest versions of Substance Engine. So you have to pick and choose based off of your needs. Hopefully Algorithmic will update their Substance Map plugin soon, but we're going to use a standard one. Once we've loaded this into the slate view, we have to load a substance. Now you can load substances that you've created or downloaded. You can also load ones that have come pre-installed with Max, and that's what I'm going to do right now. We're just going to use ones that are pre-installed. Unfortunately, the pre-installed ones do not have previews when you select them, so you have to kind of know what substance you're looking for. So I happen to know the one I want is Granite 1 for the first one. So this is going to be the inside wall. Depending on the substance, you have different outputs. This substance has a diffuse, specular, normal, bump, displacement, and height. For use in our scene, we'll use diffuse, pipe that in, pipe the diffuse to the diffuse, the specular to the specular level, and the normal off to the bump. And I want this texture to appear in the viewport, so I'm going to double click the material and click Show Shaded in Viewport. Now, you see here we have the issue of the scaling differences because each polygon on these boxes is normalized to fill up the UV space on that one polygon. I'm not going to fix that quite yet. We're going to make another substance map first and discuss a few different things here. So again, we're going to go into General, into Maps General, and find our substance. Double click our substance map and load substance. Is that they are procedural. And what that means is I can go out, double click this, and change some of the parameters. Let's change the roughness on this. Let's make it so that it's more rough, that it's a little bit deeper, and let's add a little bit of saturation to it and hue shift it to have a little bit of green here. Let's make it a little bit less saturated. All right, so it's got green. It must be moss or something on it. And now in the viewport, again, we don't see it yet because we haven't told it to view in the viewport. So I'm going to double click that and hit show shaded viewport. So now we see the top and outsides we have green. On the insides we have the desaturated lighter one. So now we're going to address the UV skewing on here. Earlier in the video we discussed using RealWorld Scale. We're not going to use that method right now. Instead, I'm going to select all of these and I'm going to apply a UVW map modifier. And again, this is the same one we looked at earlier. Notice the skewing is weird on these, and also it's only applying it to the ones that were selected, and we don't want that. So I'm going to actually delete that, and I'm going to right click and convert this to editable poly. Now we're going to go ahead and do what we had previously done, which is add a UVW map mod. Now you can see the top ones are all aligned, but again, they're not correct on the side. So we're going to change this back to box mode. And you can see the orange gizmo. That shows you the bounding box and size of the UV space being tiled. So we don't want that. We want this to be based off of the actual size of these objects. And we want it to be square. And I believe this will be 256, 256, and 256. Actually, we'll do 512. Looks like this is 512 tall. So now you can see that the tiling of this is consistent all the way across. Now, here's something to understand with how modifiers work. If you see it in italic up here, that means that this modifier is being used on multiple objects. And that means that that modifier is instanced. It's the same modifier on multiple objects. If I select this other one, the same thing. If I select this one, the same thing. So anything I do to one is going to affect all of them. So if I have this one changed and say I want to move it around, if I go to this gizmo and I want to change where this is located, I can move it around and change the offset, and it affects everything in the scene. So using this instance modifier is an effective way of controlling the UVs on multiple objects, especially in objects like this, which are very blocky and angular at 90-degree angles. The box UVW map will be effective in applying those things. So let's go over here and show another way to apply the UV or the textures and materials to specific faces. So I'm going to right click this and turn it to an editable poly, and I'm going to attach all of these other objects to it. So these are no longer 3 boxes but 1 box. And I'm going to apply our multi-sub-object material, which we made earlier. So we have these 2 materials here, and we already have it applied to those 3 objects. We're going to apply it to this object. And again, because the way the material IDs were assigned to the original boxes, we're only getting the top and the bottom on this. So to specifically say what is on these, now that this is an editable poly, this is different than earlier where we kept on cascading and adding new modifiers, poly selects and material modifiers. In this case, we're just going to select everything face by face and add them specifically. So in this case, I selected everything, and we want this everything to be set to 2 initially. So now if I get off here, all of it's green. And now I can go to polygon subobject mode instead of element mode and just select just these specific faces. And in the material ID set this to 1. So now you see the insides of there are now the gray material. Now if I want this to match that over there, I can do this. I can select the original, one of the original ones that had this unwrap modifier. I can right click it and hit copy. And then if I select this object over here, I can right click and hit paste instanced. If I paste it as an instance, it means again that anything I do to one of these is going to affect all of them. So if I change the gizmo on here, it changes everything all at once. So in this video, we've covered many core and basic principles and concepts for 3ds Max in dealing with materials and UVs. And this is by no means an exhaustive explanation of how to do things in Max. But this video should be helpful, especially if you come from a background in Hammer and are not familiar with many of the functions. In the next video, we're going to go into more depth into using Wallworm itself for basic level design. But hopefully this gave you a good introduction. Again, my name is Sean Olson. You can learn more about me at my website, seanolson.net. And you can always get the latest Wallworm tools at wallworm.com. Thank you.